Whoa, we've really covered a bunch, but we haven't even touched the scoring parameter. And as a refresh, the scoring parameter is one of the second ways that we can evaluate a model, right? So the scoring parameter is used with model evaluation tools that use cross-validation, such as model selection.crossvalscore. We've seen that one before. And model selection.gridsearchcv. Now, we haven't seen that one before, but what we're going to do is check out how we can use the scoring parameter with cross-valscore. Before we do so, let's set up a little heading. Let's remind ourselves finally using the scoring parameter. And I know there's a lot to take in, right? And I don't expect you to know everything right straight away. It's going to take a little bit of practice, a little bit of time, a little bit of effort for these things to start to sink in, right? So here we go, finally using the scoring parameter. And speaking of practice, it's one of the reasons why we keep practicing writing out, building machine learning models and splitting our data. So for model selection, we're going to import cross-valscore because that's where we can use the scoring parameter. And then we're going to import our random forest classifier. Import random forest classifier, yep. And then we can go np.randomSeed. 42, our favorite number. Again, you could use almost any number here. I actually really like the number 7 too, but 42 will do. X equals, we'll set up our X data, heart disease, dot drop. Target axis equals 1, beautiful. Y equals heart disease target, there we go. And now we can set up a classifier. And we're going to use, of course, random forest classifier, our favorite, the warhorse of machine learning. We'll set number of estimators to be in 100 so we don't get that pesky little warning that we've been getting. And we'll do that. Beautiful. So we've instantiated our machine learning model. It's ready to be fit. So we can do that here. MP random seed, we'll do it again. And we'll go CV ACK. Why are we doing CV ACK? Well, we'll see in a second, right? Cross-valscore, CLF, X, Y, and then we'll use 5-fold cross-validation. CV ACK. Wonderful. It's going to train 5 models, evaluate them on different test sets, and then, of course, we could take the mean of this. So why don't we do that? We'll go cross-validated accuracy. So we could go print F. The cross-validated accuracy is... Need some spaces here, Daniel, come on. The mean. NP mean, CV ACK. And then we're going to take that to, we'll only use times 100 and 2 decimal places. And we'll put a little percentage sign on the end. And we need a final string delimiter. Beautiful. So now the cross-validated accuracy is 82.48%. Now we've seen this before, right? We've seen this line, we've seen this line. And the reason why is we're using this is because by default, the model, it uses accuracy, cross-val score, because in essence, this is scoring equals none. So this is going to produce CVAC. And then if we go here, so now if we just copy this, right? Actually, what we might do is just test it out by only changing one thing. So if we take this, we'll copy this line just to prove it. This is where the scoring parameter comes in. So we can use accuracy here. All we're doing is changing none to accuracy. Because remember, our random forest classifier by default uses mean accuracy. So remember, the scoring parameter, when left to none, uses a classifier or estimator's default parameter from score to evaluate using cross-validation. So we'll get rid of that. Now, all we've done is we've changed scoring equals accuracy. And then we're going to take this line here. We'll just copy this. And if this is true, right, if I'm not telling lies, it should print out the exact same thing here. Because CVAC equals cross-val score, CLF, XY, CV equals 5, scoring equals accuracy should be the same as this. Let's see it. Oh, you know why it was different? It was because we forgot our NP random seed. Yes, there we go. Boom. See, that's another reason highlighting the use of NP random seed, right, is making our experiments reproducible. All right. Now, to see another metric, this is where the scoring parameter really starts to shine. How about we use precision? So CV precision to evaluate our classification model, cross-val score, because remember, precision is one of the metrics that we can use to evaluate our classification models. Now, all we're going to do is change scoring equal to precision. Beautiful. And we'll see what CV precision is. Wonderful, but we probably take the NP mean. Beautiful, so 0.82 on the precision front. We might do here, precision. Now, how about recall? So we'll go CV recall equals cross-val score, CLF, X, Y, CV equals 5. Scoring, can you guess what the scoring parameter might be equal to here if we wanted to calculate recall? Not to worry if you can't. We'll do it here, recall. And then we want NP mean to get the cross-validated recall. Wonderful, 0.84 recall. And now how about for F1? How about we do that? Yeah, why not? CV F1 equals, remember, F1 is a combination of precision and recall. X, Y, CV equals 5. Scoring equals F1. We want NP mean dot CV F1. Wonderful. There we go. Okay, now we've done some classification metrics here. How about our regression model? Well, why don't we make a regression model and check it out? Okay, from Scikit-learn.model selection, import cross-val score. So we want to cross-validate our regression model's predictions. So from Scikit-learn.ensemble, to get all the benefits that cross-validation offers, random forest regressor. Look at us go. Typing machine learning code like it's nothing. Go NP random seed 42. We'll create our X data. So Boston DF. Yes, drop target axis. Can you guess what axis? Axis equals 1. Yes. Equals Boston DF. So this is Y actually. Target. I'm getting ahead of myself. My voice can't keep up with my coding. Model equals, which is very unusual for me actually. Random forest regressor. We'll set n estimators again to being tab autocomplete to being 100. Wonderful. And now, do you remember what the default metric is for score for a regression model? So if we do model.score, the default evaluation metric is returns the coefficient of determination, r squared of the prediction. Alrighty. Well, let's check it out. So NP random seed, and then we're going to go CV r squared equals cross-val score, model this time, X, Y, CV, 5-fold cross-validation. Let's do scoring equals none, right? And then we're going to CV r squared. Then we're going to copy this exact code, boom. And because remember, cross-val score uses the default evaluation metric in the score function if set to none. So if we just change this to be R2, what do you think is going to happen? Because this is short for R squared, right? So if we go here, boom, we get the same values. Look at this. Now this is pretty drastically different, right? So we got over here, this is 0.85. This is what I was talking about of getting that lucky split. So cross-validation, on this one, it's done pretty well. So 0.85. But on this split, it's only done 0.25. So if we got here, if we did the NP mean, it's 0.622. Now that's quite a bit different to the first R squared score we saw just using the score function. Well, let's keep going. Let's not stop there. How about we do mean absolute error, because that's another regression metric. So let's try it out. So CV MAE, we'll put it in here. Mean absolute error. Wonderful. CV MAE equals cross-val score. We'll pass it our model, which is a random forest regressor, X, Y, a CV of 5. Scoring is going to be, what might this be? We might type in, we'll guess this string, mean absolute error. let's just see them all laid out, because that was pretty cool to see with our R-squared score, right? Just to see how different they can be across 5 different splits of data using cross-validation. Key error, mean absolute error. Now, why is that? And I'll tell you why. It's because we need neg in the front here. Oh, and you might be asking again, why neg? But I'll show you that in a second. Okay, so that's interesting. So if we come up here, we can tell why it means neg is because all scorer objects follow the convention that higher return values are better than lower return values, right? So that's a key point to remember here. This is in the documentation. All scorer objects follow the convention that higher return values are better than lower return values. So if we come down here, this is why we have, might zoom out because that's looking a bit too big. This is why we have neg mean absolute error. I'm looking back in our notebook. See, these values are all negatives. And the reason being is because all scorer objects follow the convention that higher return values are better than lower return values. So that means because these are negative, the higher these are, so the closer they are to 0, it's better than the lower they are. So these are pretty low, so again, our model isn't perfect. But you can see the variations in the mean absolute error values, just like we had in the R-squared values, is that some splits, right, because we did 5 splits, are offering negative 0.212. We saw 2.12 up before. But other ones we're getting a much higher one here, so negative 3.8. So this is where cross-validation really comes into play, right? Is figuring out, okay, are we just getting a lucky split on our model and training it on some easy training data to understand? And then evaluating on the test data set, we might be going, if it's a lucky split, it might be getting metrics that aren't really congruent with how the model is actually performing. So let's finish this off. We're doing mean squared error. And now I bet you can guess how to do this one. So CV MSE equals MSE for mean squared error. Cross-val score, we'll pass it the model. And then we'll do X, Y, and we'll do CV equals 5. Scoring equals. Now, if we had to do neg mean absolute error, what do you think it is for mean squared error? And if you guessed neg mean squared error, you would be 100% correct, which is the opposite to what our model is. CVMSE. Shift and enter. And again, we're seeing some quite a wide range of values here, right? So we go from negative 7.77 right up to the highest one here is negative 46.2. So we could take the mean of these to see what it looks like across 5 different splits. So negative 21.5. So that's a bit different again to our previous value when we weren't using cross-validation, right, of mean squared error, is 9.24. So naturally, if we're looking at these evaluation metrics and we're starting to see, okay, we want to get better metrics, you might be starting to think is like, how can we start to improve these metrics? How can we make them better? And we're definitely going to look at that. But finally, to finish the evaluation metrics section off, we're going to have a look at the third and final way of evaluating a model, and that is using metric functions. Spoiler alert, you've seen some of these in action before. Just to make sure we're evaluating our models correctly, we're going to have a look at those. So take a little break. We covered a lot in this video. Try adjusting the scoring parameter yourself. Don't forget, if you're getting different values, you might be using a different seed every time. And I'll see you in the next video.